In this video, you will learn how to simulate a single-stage cold drawing process using isothermal analysis module of AFDEX 2D, the Intelligent Metal Forming Simulator. Let's get started with the process type first. Since the geometries of the workpiece and the dies are axi-symmetric, we will carry out a 2D axi-symmetric simulation. The temperature change is neglected in the simulation. The information about the material is given on the left side. The dimensions of the workpiece are as shown in the figure on the left. The material of the workpiece is a steel grade and its initial temperature is equal to that of room temperature. Lubricant-coated material for cold metal forming is used in this drawing process. Therefore, a corresponding friction condition with appropriate coefficient of Coulomb friction will be selected. A constant velocity condition will be used in the simulation because the material is assumed to be rate sensitive. The die indicated by a downward arrow will pull the workpiece with a constant velocity of 1000 mm per second. The other die will remain stationary. The problem definition is complete. The result of the simulation can be seen on the right side. So now, let's see how we can simulate this process using AFDEX. Double-click on AFDEX icon to execute AFDEX in your computer. Click on New to define a new process. In this process information window we will clearly define the process type. This is 2D axi-symmetric cold drawing process, so we will make the selections accordingly. Select drawing from the different process categories listed below. Bulk forming. Select cold forming and 2D axi-symmetric simulation. We select Newton as the unit of force. So the unit of stress will be megapascal. This will be a flow analysis, which means only the mechanical effects of deformation of the workpiece will be considered in the simulation. Select elastoplastic deformation type. This means the elastic component of deformation is also considered in the simulation in addition to the plastic deformation. Since this process does not have any flash, select regular type under flash. Click OK. This is the main window of AFDEX. We will use the toolbar to set up the simulation step by step. First step is to import the geometry. Click on Model, from File, and then select the geometry file in DXF format. Click Open and then click OK. Click No to not make the overall process automatic. We will manually define the geometries in this process. Note that you can get this geometry file inside your AFDEX installation folder. Let's move on to the second step, which is to define the material property. Click on Material, from Library, and then select the steel grade AISI_1010, T equals 20 degrees Celsius, and then click Load. This will load the material into the simulation. Now click Close. The third step is to define the press machine type. As you know, we will use a constant velocity press. For using that, click on Press, Manual, enter -1000 in the fifth column of the table. This means, making the press move downwards, in the negative y direction, with a constant velocity of 1000 mm per second. Click OK. The fourth step is to select the friction formulation. Click on Friction, from Library, and then select SOAP_cold, steel, click Load and then Close. In the case of a drawing process simulation, a non-separation criterion must be defined to the die that pulls the workpiece. So let's define a non-separation die type now. Click on Die Type, Manual, and then select Non-Separation Die from the drop-down list that appears in the window. Click OK. The properties that were loaded so far will be assigned to the respective entities now. We will not be needing an upper die in a drawing process. We will use an additional lower die instead. Right-click on the upper die and then click on Delete. In the prompt window that opens, click Yes. This will delete the upper die. Now right-click on Stage 1 and then click on Insert and then click on Lower Die. Select the geometry file starting with Mold 00, drag it and drop it over the workpiece of Stage 1. Select the geometry file starting with Mold 01, drag it and drop it over the lower die of Stage 1. Select the geometry file starting with Mold 02, drag it and drop it over the lower die 2 of Stage 1. Right-click on the steel grade and select Two workpieces. This will assign the material grade to the workpiece. Select V equals 0, minus 1000, 0, drag it and drop it over lower die 2. This will be the die that pulls the workpiece. Right-click on soap_cold, steel, and then select to lower dies. This will assign the friction formulation to all the lower dies in the simulation. Select non-separation die 1, drag it and drop it over lower die 2. Now we have completed the definition and assignment of properties to the dies and the workpiece. The next step is to position the dies properly. For this, we will use the Positioner tool of AFDEX. Double-click on Stage 1 and click on Positioner icon on this toolbar. Click Auto icon. This will enable automatic positioning of the dies. Click OK. AFDEX employs an intelligent algorithm that carries out the meshing automatically and adaptively. But in this process, the remeshing function is not required. So we will turn it off. To do this, double-click on Process Control, select Remeshing, and then select None from the drop-down list and then click OK. For Stage 1 stroke definition, double-click on Forming 1. This will open the Forming Control window of Stage 1. Select Time from the drop-down menu next to Stop Criterion and enter a value of 0.012. This is the stop criterion for this stage, meaning that, when the process time reaches this value, the solver will automatically stop the simulation. After doing this, click on Volume/Mesh. We will increase the number of elements used for meshing. Select User-Defined below Number of Elements. Enter a value of 2000. Click OK. We are almost done with the simulation setup process. We just have to save the simulation, check, and run it. Click on the Save icon, enter a file name. And then click Save. Your simulation file is now saved. The final step is to check the simulation to see if we have set it up correctly. Click on the tick mark button on the toolbar. In the window that opens, click Check. This will let you know the error messages if there are any. There are no error messages in the simulation, but we can see that there is a message in the Notice section. Click on that number to see the details of the notice message. The message claims that information about velocity has not been defined for one of the lower dies as there is no press data. This notice message can be ignored though. Because if a user does not define velocity for a die, AFDEX automatically assumes the die to be stationary. After making sure that there are no error messages, click Run. This area shows stage-wise and overall progress of the simulation. On the right side are the different state variables that can be visualized based on the simulation. You can explore more on this section to investigate the state variables of your interest. The media tools here allow you to visualize the deformation behavior of the process.